One day, a farmer called up an engineer, a physicist, and a mathematician and asked them to fence off the largest possible area with the least amount of fence. Well, the engineer made the fence in a circle and proclaimed he had the most efficient design. The physicist made a long, straight line and proclaimed, "We can assume the length is infinite," and pointed out that fencing off half the earth was certainly a more efficient way to do it. The mathematician just laughed at them. He built a tiny fence around himself and said, "I declare myself to be on the outside." So his little area was actually a little cutout, and that's kind of what we'll be looking at on some of these problems with composite area. So first of all, a composite figure is made up of simple shapes. They can be triangles, trapezoids, parallelograms, and circles. There are two different ways to find the area. You can add or you can subtract. Adding is usually the simplest, but not always. And the way you do that is you slice up the figure into familiar shapes, such as polygons, which could be the trapezoids, circles, and circle sectors. Now, there can be more than one way to slice up a figure. You can see a more complex polygon or a simpler polygon. So, for example, you could see a trapezoid and just find the area of the trapezoid. But let's say you have a fear of trapezoids and you say, oh, I'd much rather do two triangles and a rectangle. Both ways will work. Honestly, the trapezoid will be faster. Once you find the area of each of the pieces, then you just add the area together. That's called the area addition postulate. Now, there are times that you actually can't slice up the area into known polygons. And in this case, you should look for cutouts. So that's kind of like the mathematician who cut himself out of the area and declared everything else inside. So you find the whole area first, and then you find the area of the cutout, and you subtract that from the whole area to get the area you're looking for. So in example 1, I'm going to use both methods. The first one is addition, and I'm going to see two trapezoids here, and I'm going to add the area of both those trapezoids. So this is adding, and the area of the trapezoid is 1/2 times base 1 plus base 2 times the height. And I had the 2 here because there are two identical trapezoids. Well, I can see base 1, one of them is 21 and one is 9, and the height for both trapezoids is 18. So I have 2 times 1/2 times 9 plus 21 plus 8 times 18. And this simplifies, so I have 30 times 18, or 540 inches squared. The other way I could do this is I could actually subtract. So I could see, aha, this is a rectangle right here, but it looks like I cut off this triangle. So if I find the area of the rectangle, the base is 36 and the height is 21. And I can subtract the area of this triangle, and the base here is 36, and the height is not quite 21, it's actually 21 minus 9. So substituting those numbers in, I have 21 times 36 minus 1/2 times 36 times 12. The 12 came from subtracting that 21 minus 9. Using my calculator, I got the same answer, 540 inches squared. In this next problem, it's a lot easier to add. There are no real cutouts going on here. And what I've done is I tried to separate the figure into some easy shapes. I notice here that this is half a circle, and that's half a circle. So I'm going to actually put them together and say this is a whole circle. Additionally, I see this triangle right here. Now, I could stop there and say that's my triangle, but wouldn't it just be easier to do one triangle instead of two? So this is another area I can find. And then finally, you can see another triangle on bottom. So I just have 3 areas to find. You could have done this separately where you're finding like 6 areas, but let's try to keep it simple. Now, the hardest part on this problem is actually finding the radius. I know this distance is 30, I know that's 16, but I don't know what the radius of this circle is. But I notice that this part here is a right triangle. So I can use Pythagorean theorem to find the radius. I drew the right triangle, and I used the Pythagorean theorem, and I found out that this distance, the whole distance, is 34. But I'm just trying to find the radius, which is half the distance. and that is 17. Then it becomes a real quick matter of using the formula for the area of a circle, pi r squared. Area equals pi times 17 squared, or 289 pi. Now if I find area 2, I need to notice that this whole distance is actually 30 plus 30, or 16, and the height is 30 plus 30, or 60, and the height is 16. So I substitute into the formula for a triangle 1/2 times 60 times 16, or 480 meters squared. Finally, I find the area of this bottom triangle. The base is still the same, it's 60, and the height is 32. So using the formula, I get 960 meters squared. Finally, I go ahead and add all three pieces together, and I get 289 pi plus 480 plus 960, or about 2,348 meters squared. On to example 2. Cheyenne is designing a logo for the color guard. The shaded areas will be purple, and the logo is 4 feet by 4 feet. So if you count this, that's 4 feet, and that's 4 feet. So how many square feet will be purple? Well, the first thing I'm going to do is the shaded area is really, it's like I took this square, then I cut out this big circle. That's where the BC is, the big circle. But then I added in 2 small circle pieces. And you could have done that. If you had taken a square piece of cloth, you could have cut the circle out, and then you could have added in 2 small circles, and that give you the same effect. So first of all, let's start with the easy part, the square. Each side is 4, so the area is 16 square feet. Now I'm going to find the big circle. The radius here is only half this distance. It is not the 4, but the 2. So the area is pi r squared, or pi times 2 squared, which is 4 pi. Finally, on the small circles, they only have a radius of 1. So their area is pi times r squared, or pi times 1 squared, or just pi. Now I'm going to go ahead and use what I had set up here, and area of the shaded is area of the square minus area of the big circle, plus 2 times the area of the small circle. Substituting in 16 minus 4 pi plus 2 pi, or 16 minus 2 pi. And actually, I really like this answer here, but if you really want to give a decimal answer, it's about 9.7 feet squared, and I really should have feet squared instead of units squared. Now, this last problem, Mrs. Overman is planning to put zoysia grass in her backyard. By the way, zoysia is very nice, but a little pricey at 52 cents per square foot. And if each grid is 2 feet by 2 feet, how much should Mrs. Overman budget to sod her backyard? So, first of all, I'm going to need to know how many square feet total that I have. I'm looking at a trapezoid right here, which is the kind of the backyard, but then I got to take out the back of this house. You can notice I did some counting on here, some measuring. Each grid is 2 feet by 2 feet, so you're going to find out I'm going to be doubling these numbers when I use them. So let's start first by finding this kind of general backyard before the house and the porch. So my plan is to find the this trapezoid for the backyard, subtract out the house, subtract out the porch and the garden and 2 trees. Now we have the garden here is, well, I'm going to do the trapezoid first, and I went ahead and counted. This is 25, this is 23, and the height's 15. So the height is actually 15 times 2 because each grid is worth 2. It's 30 feet. And then base 1 is 23. That would be this part right here. So that's 46 feet. And base 2 is 2 times 25, or 50 feet. Then I use that's this part right here. Then I use the formula for the area of a trapezoid, 1/2 times base 1 plus base 2 times height. And substituting in my numbers, the 1/2, you can actually simplify across this way with a 30. And I get 1,440 square feet. So this whole kind of this backyard area, including the house, the porch, the garden, the tree, and the tree, that's 1,440 square feet. But I'm not going to be putting grass on the garden or the porch or the house. So now I'm going to find out the parts that I'm not going to cover. Starting with the house, I know it's a plain old rectangle. The base is 36, the height is 8. So it's a very simple calculation. Base times height, which is 288 square feet. Now I'm going to find the porch, which is also another trapezoid. Remember, I'm doubling the dimensions here. Here the base was 18 times 2 is 36. Height was 4 times 2 is 8. Here the porch, the height is 5 times 2, which is 10. Base 1 is 2 times this 9, which is 18. Base 2 is 2 times that 5, which is 10. Using the formula for the area of a trapezoid, whoops, let me come back up. Using the formula for the area of a trapezoid, I get 1/2 times 18 plus 10 times 10. And I simplified the 10 with the 1/2 to make it a little easier. And 18 plus 10 is 28 times 5. That's a times, not 0.5. And I get 140 feet squared. Now I'm going to look at the garden piece and the tree piece. So with the garden, I have an area of, each side is 5, but I need to double it. So the base is 10, 5 times 2, and the height is 10, 5 times 2. Just use the formula for the area of a triangle, and I get 1/2 times base times height, or 1/2 times 10, which is 50 square feet. I can do the same thing with the tree. Now, the tree has a radius of just 1 unit. So the area of the tree is pi r squared, or pi times 1 squared, or just pi. Now I'm going to go ahead and pull up the formula for the entire area. And with that formula, I get 956 square feet. So I subtracted the area for the, I took the area of the big trapezoid, subtracted out the house, the porch, and the garden, and 2 of the little parts for the trees. And I got 956 square feet. And now I forgot to add one little piece. I need to calculate the cost. So since I know that 950 square feet, that's how much I'm going to need, I multiply that times the 52 cents per square foot. So it should be about $500, but I'm going to take my calculator right now, 956 times 0.52, or 52 hundredths, and I get $497. $497.12. So about $500 to resod the garden.